afternoon, guys. We have completed half part of the unit number 4. Today we will going on the second part, design of pressure vessel. In this design of pressure vessel, we will cover the topics: introduction of the pressure vessel, unfired pressure vessel, then types of the welded joint used in a pressure vessel, categories of welded joint in unfired pressure vessels, classification of unfired pressure vessel, then selection of the material for unfired pressure vessel. We will study only the unfired pressure vessel. Okay. Then selection of the design parameter in unfired pressure vessel, design unfired pressure vessel, design of pressure vessel cell, then design of different types of the end closures in unfired pressure vessel, and design of the nozzle and opening in the unfired pressure vessel. Then second last, support for the pressure vessels. There are different types of the support given for the pressure vessel. Okay, for the horizontal and vertical pressure vessel. We'll see in details. Okay, this syllabus is given in your syllabus. Okay, then next we'll going on the next slide. First we'll see the introduction of the pressure vessel. Student, do you know the what is mean by pressure vessel? Pressure vessel are the containers or pipelines used for storing, receiving or carrying the fluid. Okay, different types of the fluid under the pressure. It is called as a pressure vessel. Okay, very simple definition. Pressure vessel are the containers or pipelines used for storing, receiving or carrying the fluids under pressure. Okay, the fluid being stored may remains as it is, as in case of storage vessel, or may undergoes the change of state while inside the pressure vessel, as in case of steam boiler. Okay, storage vessel fluid storage remains as it is, I have told already. Steam boiler fluid undergoes change of state. Then chemical process, this is the combination with the other reagents. Pressure vessel designed with a great care of the failure of the vessel in service or loss of life and property, different types of the properties. We are using to make that pressure vessel with the help of different material like brittle, for example cast iron, then second ductile, or we can say the for example plain carbon steel and alloy steel. Okay, then there are two types of the pressure vessel, unfired pressure vessel and fired pressure vessel. Okay, unfired pressure vessel and fired pressure vessel. We'll see what is mean by fired pressure vessel and what is mean by unfired pressure vessel. Unfired pressure vessel are all vessels, or we can say the pipelines and the like of carrying, storing or receiving the steam, gases or liquids at pressure above the atmospheric pressure. Very important, remember that this pressure stored in the pressure vessel above the atmospheric pressure. Okay, the I squared is used, international standard code is there. Okay, 2825 and 1969 code for the unfired pressure vessel, prepared by BIS. What is the BIS? Bureau of the Indian Standard. Okay, is commonly used in the design of the unfired pressure vessel. The example of the unfired pressure is storage vessel, reaction vessel, autoclave, heat exchanger, evaporators, crystallizer, distillation column, etc. The steam boiler and the nuclear pressure vessel are vessel do not come under the unfired pressure vessel. This is coming under the fired pressure vessel. Okay. Then there are different types of the joints, welded joint used in the pressure vessel. You know there are three types of the welded joint commonly used in the pressure vessel. Which three types of the pressure vessel? Double welded butt joint with full penetration. Full penetration means you have given the joint efficiency. Okay. Fully radiograph, then spot radiograph and not radiograph. Okay. Then second is a single welded butt joint with backing strip. They have given support with the backing strip. Then single welded butt joint without backing strip. Then next single full fillet lap joint. Okay. The welded joint efficiency is defined as the ratio of strength of the welded joint to the strength of the plate. Strength of the plate. Remember that. Okay. Then next one will going on the design criterion. Okay. What is the design criterion for the unfired pressure vessel? Unfired pressure vessel. Yes, cylindrical pressure vessel depend on the function. There are two types of the pressure vessel, horizontal and vertical. In the horizontal, we are prepared for a thin walled vessel operating under the low pressure. Those pressure vessel operating under the low pressure vessel means operating internal pressure is less than 10 MPa or Newton per mm square, rolling or welding. Okay. Then reduce the bending stresses. How to reduce the bending stresses? This is depend on the weight of the vessel and fluid in the vessel. With the help of that two things you can reduce the bending stresses in the pressure vessel. Second is a vertical pressure vessel. Okay. Operating internal pressure is less than 10 MPa is called rolling or welding, and greater than 10 MPa we are using the forging process. Okay, remember that both when we use the rolling or welding, when we use the forging. This is very important. Next, failure modes in a pressure vessels. Why pressure vessel will be fail? Okay, there are some reason behind that. We'll see one by one. Improper material selection. Guys, you should select the proper material to make the pressure vessel. As per the given data, you should select the correct material for the made the pressure vessel. Then corrosion, inaccessible pockets. Okay. Then fatigue failure, improper prediction. That's why you will get the fatigue failure. Then thermal stresses, it is also called as a temperature stresses or temperature gradient. In the pressure vessel, there are different types of the stresses, thermal stresses are induced. Okay. Then next, wind energy. Okay, seismic activity. Because of wind energy, you should consider for the vertical vessel. Okay, wind stresses and seismic stresses. And pipeline load, again you should consider the piping load for the failure to recognize. Then next is a brittle and creep failure. You have learned all these things before that in material science. Improper welding, you have to check the properly welding. Okay, failure at seams. Okay, opening is there, closing is there, then again nozzles are there. That's why you have to check the proper welding of the pressure vessels. Then next, classification based on the classification of the pressure vessel is based on is code. Okay, you know how to compare that. There are three classes: class 1, class 2 and class 3. Okay, in class 1 pressure vessel that contains what contents is included in class 1 vessel. Operating these vessels are operating below minus 20 degrees Celsius. Remember that. Then we are using welding, fully radiographic welding. Okay, and we are using double butt welded joint and butt with backing strip. Remember that. In the class 1, how to identify the given pressure vessel is a class 1, class 2 or class 3. Okay, remember that thing. Vessel operating pressure below temperature below minus 20 degrees Celsius, and the welding joint is fully radiography. Third is a double welded butt joint we are using, and again butt with backing strip. Then we are using the different substances such as hydrocyanuric acid. Then we are using the different types of the gases, carbonyl chloride, cyanogenous, etc. Remember that. Then see the class 2, how to identify the class 2, or before going on the class 2 we'll see the class 3. The vessels used for working pressure, check that what is the working pressure, not exceed than 3.5 bar. Okay, those pressure vessel having the working pressure less than 3.5 bar, this pressure vessel coming under the class 3. Vapor pressure is 17.5 bar. Okay, and hydrostatic design pressure. Okay, remember that these two value, the vessels used for working pressure not to exceed than 3.5 bar, vapor pressure or 70.5 bar, hydrostatic design pressure. Okay, and the vessel operating in temperature range, remember that this temperature range 0 degrees Celsius to 250 degrees Celsius. Okay, 0 degrees Celsius to 250 degrees Celsius. With the help of that you should identify the given class. Already I have told the welded joint. Which welded joint is used here in class 3? Double welded butt joint with full penetration. In class 1 we are using the fully radiograph, but here we are using the fully penetration. Okay, again we can use the single welded butt joint with backing strip in the class 3. Okay, and without backing strip. Single fillet lap joint we are using for the circumferential joint only. Circumferential joint we are using, again these are coming in the class 3. Okay, you should remember the classification of that unfired pressure vessel on the basis of class 1, class 2 and class 3. Okay, next, categories of the welded joint. There are 4 categories are given in the welded joint. Okay, which 4 category is given? The term category specify only the location of the welded joint in the pressure vessel and does not imply the type of welded joint. Category A, Category B, Category C and Category D. Consider this location and categories of welded joint with the help of that figure. How to calculate the welded joint efficiency? It is the ratio of strength of the plate to the strength of the welded joint. Okay, in this category we'll see one by one. Okay, category A consists of longitudinal welded joint within the main cell and communicating chamber, or we can say the nozzles. In the category A, see longitudinal welded joint within the main cell, communicating chamber or nozzles. We are using any welded joint within the form or flat head. There are different types of the head. You can observe in this figure. Here is a category A shown in the circle. Okay, there we are using the category A. A, or where we'll get the circumferential welded joint connecting end, or we can say the closer to the main cell, where we'll close that cell, there is we have the circumferential welded joint. Okay, at that place also we are using the category A. Then category B, check that. Category B consists of the circumferential welded joint within the main cell, within the main cell, and we are using the communicating chamber or nozzle. See the category B, communicating the chamber or nozzle, where we have placed the nozzle. We are using there the category B, or where we'll get the circumferential welded joint. This circumferential welded joint within the main cell only. Okay. Then category C. Category C, it consists of the welded joint connecting flanges, where we are using the flanges and flathead to the main cell, or we can say the form head or nozzle. There we are using the category C. Check that category C, where is the nozzle, main cell. Okay, here is a opening are there. Okay, or we can say the form head. Okay, there we are using the category C. And last is a category D. Category D consists of the welded joint connecting communicating chamber or nozzle with main cell. Communicating chamber. See the category D. Rarely we are using the category D. For example, where we are using the closing or opening, at that place we are using only the category D. For example, manhole. If you are doing any maintenance, okay, then you should you have to go inside the cell pressure vessel. At that place we are using the D category. Okay, if there is any opening, then we want to insert the liquid in the pressure vessel, that place also we are using the category D. Remember that. Okay, all of you getting types of the welded joint and their joint efficiency. Okay, then next one we will going on the next one, selection of material for unfired pressure vessel. Okay, this is very important. This selection of material is depend on the different operating condition. Okay, different operating condition means what? There is a high or low temperature, high pressure or low pressure. You have to check all these operating condition. First operating condition is a high or very low pressure or temperature. You should remember that. Low temperature, then which material is select. Okay, if the high temperature, then which material will select. If there is a high pressure, high flow rates, okay, corrosive atmosphere, and sometimes corrosive fluid is there inside the pressure vessel. Okay, remember that this is the operating conditions. Based on again required mechanical strength, you have to check the mechanical strength also, other mechanical properties, anti-corrosion property, fabrication problem, commercial availability of the material, and cost of the material. We will select the material based on that operating conditions and mechanical strength, mechanical property, corrosion properties, or we are consider all these things. Material is used for the unfired pressure vessel. There are different types of the materials are used for unfired pressure vessel. First is a cast iron, second is a plain carbon steel, third is a alloy steel, fourth is a aluminum alloy, fifth is a copper and copper alloy, sixth is a nickel and nickel alloy. Okay, cast iron, they are divided into the different types. Gray cast iron is there, then alloy cast iron is there, plain there are two types. Okay, gray cast iron and alloy cast iron. We will see the details. Gray cast iron, Grey cast iron, when we use the grey cast iron, these are not corroded by acid alkali solution less than 30% of concentration at any temperature. Okay, means we are using the acid or alkali solution of less than 30% concentration at any temperature. Therefore we are used for acid reaction vessel, okay, all alkali reaction vessel. At that time we are using the grey cast iron. Second is a alloy cast iron with silicon as alloying element. Okay, alloying element having the good chemical and corrosion resistance. It is a practically unaffected by the sulfuric acid. Remember that it is practically unaffected by the sulfuric acid. Okay, or we can say the hydrochloric acid and nitric acid at all strength and at all temperature. Okay, they are having the good good property at all temperature, having the good strength, heat resistance, toughness, castability and machinability, all having the good property. Add up 3% of MO resistance to HCl and Cl containing chemicals. Okay, remember that when we will getting that type of the property, then you should use the alloy cast iron with silicon as alloying element. Then next second material is a plain carbon steel, 15C8, 20C8, 30C8 are most commonly used for the light duty vessels. Okay, light duty vessels, where we want to use the light duty vessel, at that time you should choose the plain carbon steel. Okay, due to the poor chemical resistance, okay, due to the poor chemical resistance, chemical and corrosion resistance, plain carbon steel pressure vessel are not used in convective atmosphere. Okay, corrosion atmosphere, due to the poor chemical resistance, so we not use in the corrosive atmosphere plain carbon steel. Third is a alloy steel. Alloy steel, see where we, when we use the alloy steel with carbon content of the 0.2%, okay, magnesium 1% and chromium 1 to 3%, then up to 0.5% molybdenum up to 0.5% and silicon about the near about 0.3%. okay, this type of material is used for the high temperature, where we will get the high temperature and high pressure. Okay, high temperature and in the pressure vessel, then we are using the alloy steel. Then there are different types of the alloy steel. Low alloy steel, again see the carbon content is 0.2%, nickel is 1 to 4%, chromium is 1 to 3%, then molybdenum up to the 0.5% and silicon is a 0.3%. you should remember the contents, what is the carbon contents, nickel contents, etc. are used for the, and also thick walled heavy duty pressure vessel in chemical and petroleum industry. Okay, where we are used this application of this alloy steel pressure vessel in chemical and petroleum industry, because we will get the maximum percentage carbon, nickel, chromium, all these are getting in the chemical and petroleum industry. That's why we are using the alloy steel material when you made up of the pressure vessel. Okay, then second type is the high alloy chromium nickel steel. High alloy chromium nickel steel and chromium nickel molybdenum steel. Okay, remember that pressure vessel operating at sub-zero temperature. Okay, when we use that pressure vessel operating at sub-zero temperature means very high temperature or handling highly corrosive fluid. Okay, very high temperature or handling high corrosive fluid. They are also used in the food where we are using food processing and dairy plants, where we are using that dairy plant and food processing industry. Okay, all of you getting alloy steel, very important. Maximum time when you design the pressure vessel, okay, for the petroleum or chemical industry and food processing and dairy plant, we are using the alloy steel. Okay, next is a fourth is a aluminum alloy. Okay, the property of the aluminum alloy to resist the attack by the acid. Okay, to resist the attack by the acid. Therefore, in the use for a storage and reaction vessel, handling nitric acid, hydrogen peroxide, organic solvent, seawater and foodstuffs. Okay, these some examples are given where we use the aluminum alloy pressure vessel. Okay, they are suitable for the given temperature range minus 150 degrees Celsius to plus 150 degrees Celsius. Where we'll get that range minus 150 degrees Celsius to plus 150 degrees Celsius. There we are using the aluminum alloy material. And second last material is a copper and copper alloy. Okay, where we are use the copper and copper alloy, we are used in the food industry or food processing plant. We are using in the manufacturing and recovery of the organic solvent in heat exchanger and evaporator. Okay, in the evaporator and heat exchanger, for making that too, we are using the material copper and copper alloy. Because of there are various copper are used, for example CuZn30, CuZn37. This is the grade of that material is given. Okay, different material we are using for design of the pressure vessel. Okay, remember that. All of you getting how to select the material, you should remember the property of that material. Okay, copper and copper alloys. The next is a nickel and nickel alloys. Okay, nickel and nickel alloys where we are used for handling corrosive fluid at elevated or low temperature, and where it is necessary in the prevent where contamination of fluid to be prevented. Okay, this fluid is prevented, there we are using the nickel and nickel alloy material. Okay, whereas nickel alloy are very expensive. They are primarily used as a cladding material in a steel pressure vessel. Remember that we are using cladding material in a steel pressure vessel. Okay, you should remember the property of the material, then with the help of that material property you can choose the material for the unfired pressure vessel. Okay, next is the selection of the design parameters. Okay, selection of the design parameters of unfired pressure vessel. Okay, the design parameter of the unfired pressure vessel begins with the selection of the design parameters. Which parameter we will consider? First is the maximum working pressure. Okay, you should check the maximum working pressure to which subjected to the pressure vessel. Then design pressure for which the pressure vessel is designed. Then hydrostatic test pressure. Hydrostatic test pressure. Fourth is a allowable design stress. There are a different types of the stresses are induced, but you should check the which stress are induced. You have to consider the sigma all allowable design stress. Okay, and also you have to consider the corrosion allowance. Design start with selection of design parameter. I have write in design pressure first, then allowable stress, then corrosion allowance. And design pressure, in the design pressure you have to remember that maximum pressure, design pressure, hydrostatic test pressure. Okay, the hydrostatic test pressure is equal to 1.3 design pressure. The relation is given, and design pressure is denoted by the PI is equal to 1.05 maximum working pressure. You should remember that relations. Okay, when you solving the numericals, then we want to use that relation. What is mean by maximum working pressure or Pmax? Maximum working pressure is the maximum pressure to which the pressure vessel is subjected. Okay, you should remember the working pressure is the maximum pressure to which the pressure vessel is subjected. What is the design pressure? It is denoted by the PI. It is denoted by the PI. Design pressure is the pressure for which the pressure vessel is designed. What is mean by design pressure? Design pressure is the pressure vessel which the pressure vessel is designed. Design pressure already I have told, PI is equal to 1.05 maximum working pressure, or you can say the PI is equal to 1.05 Pmax. Okay, this is the relation. What is the hydrostatic test pressure? Hydrostatic test pressure is the pressure at which the vessel is tested. Vessel is tested before it is put in the operation. Before putting in the operation the pressure vessel, you have to check with the help of hydrostatic test pressure. That's why it is called as a test pressure. You should first test with the help of that pressure. The relation is the hydrostatic test pressure is denoted by the pH is equal to 1.3 design pressure. 1.3 design pressure. Okay, then there are a we are using the two codes. Okay, we are using the two codes. The as per the IS code, how to calculate the sigma all. As per we are using two codes, IS code and ASME code. Okay, American standard and Indian standard. We are using that two code is based on the SUT. You know the what is mean by SUT? Ultimate tensile strength and factor of safety 3 or 4, 3 and 4. As per the DIN code IDS based on the SYT. SYT means what? Ultimate tensile yield tensile strength, and factor of safety for that 1.5. I will write here relation sigma all is equal to SUT divided by NF. Factor of safety. What is the factor of safety for that IS code? 3 is there. 3 is there. That's why formula you will get the SUT divided by 3. And second is as per the ASME code, this ASME code again you will get the SUT divided by NF. Okay, SUT divided by NF. Again we are consider the ultimate tensile strength divided by 4. Okay, if you have given the ASME code, and if you are using the DIN code, then you should choose the SYT divided by NF. SYT divided by NF is 1.5. 1.5. Then again we are using, all of you know that what is mean by sigma allowable tensile stress. Last unit also we have seen design of pressure vessel, the meaning of that sigma all. This is given in Newton per mm square. SUT ultimate tensile strength. Okay, for the pressure vessel material, this is also given in Newton per mm square, and yield strength for the pressure vessel SYT. Okay, this is also given in Newton per mm square. Then next is a corrosion allowance. It is denoted by the C. What is the reason for the corrosion allowance in pressure vessel? We will get the corrosion allowance in the pressure vessel. First, because of chemical attack. Okay, because of chemical attack by the reagents on the inner surface of the vessel. That's why we will get the corrosion. Second is a rusting due to the atmospheric air and moisture. Okay, rusting due to the atmospheric air and moisture. Due to that we will get the corrosion. High temperature inside and outside of the pressure vessel will get the oxidation. Okay, high temperature oxidation. And last is a erosion. Erosion due to the flow of the reagent over wall surface at high velocity. That's why also we'll get the corrosion. That's why we want to consider some corrosion allowance. Okay, corrosion allowance. These guidelines are provided by selecting of the corrosion allowance. Corrosion allowance means, what is the corrosion allowance? It is the additional thickness of the pressure vessel wall. Remember that. If the pressure vessel thickness is a 2 mm, then we are consider again more than 2 mm, that corrosion allowance wall thickness, over and above the required to withstand the internal pressure. Okay, very simple. You should remember that. Different material having the different value of the corrosion allowance. Okay, the guidelines are given. Corrosion allowance for the CI, cast iron, plain carbon steel and alloy steel component. Okay, if you have given that material, then you should choose the corrosion allowance. C is equal to 1.5 mm for normal condition. If there are chemical inside the chemical industry, you should use the C is equal to 3 mm plus 3 mm plus 3 mm. Then when thickness of the cylinder was for high alloy steel and non-ferrous component, no corrosion allowance needed. Okay, there is a, we are consider the corrosion allowance is 0. Okay, high alloy steel, if the material is high alloy steel and non-ferrous component, we are not consider the corrosion allowance. When the thickness of the cylinder wall or T is greater than 30 mm, then again no need of the corrosion allowance. Again we are consider the 0 corrosion allowance. 0 corrosion allowance. Guys, today we'll stop here. Okay, you should remember all this theory part when you solving the numericals or design of the pressure vessel. Okay, at that time all the theories are required for the unfired pressure vessel. How to select the material, how to choose the material. Okay, remember the property of the material. Then again remember the types of the welded joint used in the pressure vessel. Okay, then selection of the design parameters. Okay, selection of the material for the unfired pressure vessel. We have seen all these things. And also important thing, you have to classify that unfired pressure vessel under the class 1, class 2 and class 3. Okay, and also we have seen the different categories of the welded joint in the unfired pressure vessel, A, B, C and D category. All these things you should remember. Today we'll stop here. Next lecture we'll going on the remaining part. Thank you.